Today, we're going to talk about something really fascinating called Gem Anything. You know, the core idea is actually pretty simple, but wow, is it ambitious. What if you could turn any software, I'm talking everything from super niche engineering tools to huge enterprise systems, into a realistic training ground, a gym for AI agents? Let's dive into how they're making this happen.
So here's our game plan. We're going to start with the big problem that kicked this whole thing off. Then we'll get into the Gym Anything framework and its powerhouse, the creation audit loop. We'll also see how they scale up task generation, test an agent's ability to stick with a problem, and finally, we'll cover how you can actually start using it yourself. All right, so let's get right into the why. The whole reason this project exists is to solve something called the benchmark gap. And it's a huge disconnect, really, between how we're testing AI agents right now and the kind of complex work people do on computers every single day. I mean, just look at this slide. It says it all. On the left, you've got a basic web form. This is the kind of stuff we usually see in AI benchmarks. But on the right, that's FreeCAD, a professional engineering tool. The complexity is just on a completely different planet. And it's where, trillions of dollars of real economic activity actually happen. And this really brings us to the key question, doesn't it? If the whole goal is to get AI to help with or even automate professional work, then why are we spending so much time training and testing them on tasks that look nothing like that real-world work? Yeah, this quote from the paper just nails it. This gap has two major problems. First, our tests aren't really telling us the truth. A high score on a simple task just doesn't mean much when it comes to handling complex software. And second, it means our training data is kind of weak. It's missing the rich, long, complicated examples we need to build agents that are genuinely capable. So, what's the fix? Well, that's where Gym Anything comes in. It's a scalable framework built specifically to close that benchmark gap. The whole point is to create agent environments that have real economic value and actually mirror the work that gets done in the real world. Okay, this gives us the 10,000-foot view of the whole pipeline. It all starts with phase one. They use GDP data to pick software that's economically important. Smart, right? Then in phase two, AI agents actually turn that software into a training environment. Phase three is all about creating tons of tasks, and phase four is where they evaluate how well the agent performs. We're about to dig into the most interesting parts of this whole process. So here's the absolute key, the big shift in thinking. Gym Anything basically says, instead of having humans slowly build every single environment, let's turn environment creation itself into a job for a team of AI agents. And that right there is the secret sauce that lets it scale and handle pretty much any software you throw at it. All right, let's pop the hood and look at the engine room of this thing. The real innovation here is a multi-agent system they call the creation audit loop. It's basically AIs building and double-checking environments for other AIs to train in. Pretty cool. Now, this diagram shows you the workflow. You've got a creation agent that does the heavy lifting. It's writing setup scripts, downloading all the data you need, and then it produces evidence, things like screenshots and log files. But then, on the other side, you've got an independent audit agent that comes in and inspects all that evidence to make sure the environment is actually good to go. The best way to think about it is like a pair programming team, but for AIs. The creation agent is the builder, right? It's writing the code, setting everything up. The audit agent is the inspector. It's almost like an adversary, reviewing the builder's work. It takes all the evidence, the screenshots, the logs, and checks it against this super detailed quality checklist to catch any mistakes the builder might have missed. And here's where it gets really smart. Both of these agents write notes to a shared memory. The creation agent documents what worked, what failed, all the nitty-gritty details. But to make that useful, a third memory summarization agent comes in, reads all those notes, and boils them down into general, reusable tips. Stuff like, hey, always run this command after you install software X, or watch out for this specific error on Windows. This lets the whole system learn from its mistakes and successes, making every future setup faster and more reliable. Okay, so you've used that loop to build a few really high-quality environments. Awesome. But how do you go from a handful of environments to literally thousands of useful training tasks? Well, this is where a strategy they call propose and amplify comes into play. It all starts small. Just a tiny number of super high-quality seed tasks. In their example, it was just 5. And these aren't just any tasks. They're created by a really powerful and, let's be honest, expensive agentic model. One that can actually play around with the software to design challenges that are realistic, tough, and diverse. And then comes the magic, the amplification.
They take those 5 amazing seed tasks and feed them as examples to a much cheaper language model. This second model can't interact with the software, but it's great at pattern matching. So it just takes those examples and spits out thousands of new, varied tasks. It's a brilliant and efficient way to scale up.
Now, the reason this is so important is that this propose and amplify trick massively boosts the quality. They found that without those seed tasks, the success rate for setting up the generated tasks was only about 55%. But by giving the model those really good examples to learn from, the success rate skyrocketed to almost 89%. That's a huge improvement in reliability. So, what's the payoff for all this work? How does it actually help us test agents better? Well, the framework was used to build CO World, which is a new benchmark designed to test a really crucial AI skill: persistence. The ability to stick with a long, complicated task. A big part of this is COI World Long, and when I say this is a tough benchmark, I mean it. It's a set of 200 tasks, one for each piece of software. And these are not just a few clicks, these are long horizon challenges, often needing more than 500 steps to finish, which is just way beyond what most benchmarks are testing today. Now, on these really long tasks, the researchers noticed agents were failing in a very specific way. They would just stop too early. They'd claim the task was done when in fact it wasn't. But it turns out applying that same auditing idea from the environment creation stage led to a pretty big improvement. And this chart shows you exactly what happened. They implemented something called test time auditing. Basically, when the main agent says, "I'm done," a separate audit agent comes in and reviews its work. Just doing that unlocked a nearly 22% performance boost. The success rate went from 11.5% to 14.0%, simply by having that second agent catch those early stops and tell the main agent, "Hey, you missed a few things." So if you're a developer watching this, you're probably thinking, okay, this is cool, but how can I actually get my hands on it? So let's take a look at the toolkit that ships with the Gem Anything library.
Everything really boils down to this one standardized file, env.json. This thing is the blueprint. It defines everything from metadata and what the environment needs to run to the specific interfaces the agent will see and use. It can even handle defining different user accounts, which is great for creating realistic enterprise scenarios.
And the library is built to be flexible. As you can see here, it supports Linux, Windows, and even Android runtimes. It can use different compute backends like Docker or Aptainer, and as a dev, you can specify exactly what hardware it needs: CPU cores, GPUs, and define those standard interfaces the agent will use, the screen, mouse, and keyboard. So this all leads us to a final and pretty exciting question. The real breakthrough here is that we can now turn pretty much any piece of software into a training ground for an AI. So with this newfound power, what are the truly complex, real-world problems that we're going to task our agents with solving next?